arithmetic the first lecture. Let's continue the same. We studied about sequence and what is series. We are discussing about what is an arithmetic progression. That is simply a sequence in which a certain rule is followed, and that particular rule is that the common difference between all the terms, the common difference between any two consecutive terms is always the same. That's one thing about arithmetic progression, and using the same property, we will find it out different formulas for it. You will find it out the nth term of like nth term for any arithmetic progression, and also the sum of n terms, and also how we can find out the nth term from the sum of n terms and sum of n minus 1 terms, and also the formula of sum of n terms. Great. So this is the condition of three terms being in AP, and it's very, very important. It's used in questions very much. So if you are looking for like condition for three numbers, then I would like to tell you the example of an AP being three in numbers and also in AP. So one, two, three. It is a good example. You can consider whenever there is mentioned like there are three terms and they are in AP. So you can mention these numbers as in your example. They are very simple to solve in any calculations. Clear?
Yes, sir.
Yep. So we discussed about the properties of arithmetic progression, various properties, highly important for questions. Okay, so this was the case of assumption when we have to assume any terms, then how we can do so, and basically why we are assuming in this method so that we can find out the sum of all in terms of a only. Okay, when we will have only single variable, then it will be easy for us to calculate for it and find out the remaining. Okay, let's move to the question now. The sum of the first five terms and the sum of first 10 terms of an AP are same. Which one of the following is the correct statement? So it is given to us the sum of first five terms means S of 5 is equal to the sum of first 10 terms. Then we have to find out what is correct. So the options are talking about first 10 being negative, the common difference being negative, either A negative or D negative, or both of the common difference and the first term being negative. Let's see first what we have is this. Let's solve this. So sum of five terms, formula for this is 5 by 2. Basically n by 2 plus n by 2, 2a plus n minus 1 into d. N minus 1. So 5 minus 1 into 1, that becomes 4d. This becomes 10 by 2, 2a plus 9d. Now this becomes 5. 5 cancels 5. This cancels this, and this becomes a plus 2d on the left hand side. This becomes 2a plus 9d on the right hand side. Solving it further makes it a plus 7d equals to 0. Okay. So it means that a minus of 70 is equals to 8. Now from this we can conclude that if A is positive, then D is for sure. If A is positive, then D has to be negative. If A is negative, then D has to be positive. Clear? Only then, if A is positive, then product will only make it positive. So D has to be negative for that. So if A is positive, D has to be negative. If A is negative, then of course D has to be positive to make the whole product negative. Okay, so this is one condition that we can conclude for. So it is for sure that the first term must be negative, but it have a condition. If the first term is negative, then the D has to be positive. So we cannot say a single statement only. Either the first term or the common difference is negative, but not both. Yes, this is the point that our result is talking about. Clear? Any doubts?
No, sir.
Yes, can also read it here. Okay, let's discuss about this example. If the ratio is the sum of m and sum of n terms of an AP is m square is to n square, then the ratio of mth and nth terms, then we have to find out the ratio of mth and nth terms. Okay. So is it given to us? Yes, it is given to us that the sequences of AP. So sum of m terms will be what? M by 2 into 2a plus m minus 1 into d divided by n by 2 multiplied by 2a plus n minus 1 into d is equals to m square to n square. 2 cancels 2, m cancels m square, n cancels n square. Now this becomes 2a plus m minus 1 into d divided by 2a plus n minus 1 into d equals to m by n, right? Now, we have to find out the ratio of mth and nth term. Basically, so how we can find out? Basically, what is mth and nth term? This is a plus m minus 1 into d and a plus n minus 1 into d. This is what we have to find out. Okay, so we can spot one thing here is that we can use component dividend rule, and then we can solve for it further. Okay, first let's solve it further. We can do we can write it as a plus a m mth term, a plus m minus d, which is the mth term. We can write it as a plus nth term. Okay, clear. So this is clear to us. And now let's apply the component dividend rule on this. So a by b, if c is equals to c by d, so it says that a we can write a plus b minus a by minus b, c plus d on c minus of d. This is what this rule says. Okay, so okay, let's do it. Let's try. So a plus b means a plus t mth term plus a plus nth term divided by a plus mth term minus a minus nth term is equals to m plus n divided by m minus of n. This becomes 2a plus mth term plus nth term divided by mth term minus of nth term equals to m plus n divided by m minus n. Okay, now Let's solve further and try to solve. Now we are missing actually something. If the ratio of sum of m and n terms is this, then the ratio of mth and nth term. So, okay. So, what if we try another approach, because from this we are not concluding any solution. Sum of m terms and sum of n terms. Okay. So let's consider one thing. Ki let n becomes m minus of 1. Okay. So what is mth term? Is basically sum of m terms minus sum of m minus 1 terms. We can write it from the formula that we studied this, right? From this we can write. So let's say here the sum of n terms is basically m minus 1. Okay. So this becomes sm divided by sm minus 1. M square becomes m square only, and was m minus 1. Cool. Now we can approach. And so Sm into m minus 1 whole square, m square into s of m minus 1. Okay. So we have to find out the mth term, which will look like this. Okay, let's solve for this. M minus 1 whole square, m square plus 1 minus of 2n is equals to s of m into m square minus m square. This becomes m square, s of m will cancel this and this. Okay, so now this will become s of m minus of 2m into s of m is equals to minus of m square. If we further write it, we can write it like this: m square minus of 2m into s of m plus s of m is equals to 0. This is one equation after solving this table. So what we needed to actually find out, we misunderstood s of m minus s of m minus 1 is actually here. Okay, we are doing a mistake. Okay, so let's try another method. This method is assumption method. If nothing works, this will for sure work. This is a AP, right? We have to find the terms ratio. So simply let m is equals to 3, n is equals to 2. ठीक है. Simply just let it. Sum of n terms, sum of 3 terms, sum of 2 terms should be 9 by 4. Cool. So what is the sum of 3 terms? 3 by 2 into 2a plus n minus 1, that is 2 into d, divided by 2 by 2, 2a plus d is equals to 9 by 4. Let's cancel this cancels 9 by 3 and 4 by 2, this becomes okay. So this can also, 2 can be taken common from here. So a plus d divided by 2a plus d. 2 was common here, so 3 by 4 now. Okay, simple. And now if we solve it further, so we can write 4a plus 4d is equals to 6a plus 3d. Now this becomes 2a, 2a is equals to d. This is the condition. We had to find out Tm upon Tn. Tm is a plus m minus 1 into d. M is 3. So a plus 2d and a plus d. Simply we had to find out this. A plus 2d into a plus d. Okay. So now we know d is what? D is what? 2a. 4a plus 2a. Now a plus 5a upon d is what? 2a. This is 3a. This should be 5 by 3. Tm by Tn should be 5 by 3. Now, as per our assumption, M was 3 and N was 2. M was 3 and N was 2. Let's modify the options and see where our answer is 5 by 3. So 2m minus 1, that becomes 6 minus 1, 5, divided by 2n, 4 minus 1, 3. Okay, first option is matching. 2m plus 1 becomes 6, 7 is to 4, 4 minus 1. So 3. So second option is not matching. Array 3. My laptop is not responding. So what technique which we actually are following is the assumption method because nothing else works. And this is the fastest method, assumption. We have assumed m is equals to 3 and n is equals to 3. B option becomes 7 is to 2. C option becomes 2n minus 1. So 4 minus 1, 3 is to 2m. 6 minus 4 is 2. D option, none of these. So A option is matching as per assumption. Sorry, A option should be our correct answer. Let's go and check the answer. Yes, A is the correct answer. And how they have solved? Okay, after this, they have done this. Okay, anyways, simply they have also find out the what should I say? The relation between D and A. And we have also find out the relation between D and A. So it's two-way. But here we have to consider that we went smart and we assumed M and N's value, and that's how we solved it in a single page instead of going here because there was tedious calculations here, right? Any doubts, anyone, or should I repeat?
No, sir.
Okay. This method of assumption is very, very important to use because this solves our question. And trigonometry also, you will come to know that assumptions will help you to solve questions. Okay, so this was all about arithmetic progression. Let's now study about the next sequence type, which is geometric progression. Are you ready? Or do you have any doubts regarding AP? Any doubts?
No, sir.
Okay, so what we are studying were arithmetic progression. Progression. And what was the unique feature was common difference, the difference. And the property said that the middle term, if there are like A, B, C are in AP, so the middle term is the arithmetic mean. So actually, let's talk about arithmetic mean a little. Arithmetic mean is sum of observations, all observations or elements or terms divided by number of observations or elements. That is basically arithmetic mean. If I give you 5 elements like 2, 2, 3, 4, so 2, 2, 3, 5, 7. These are 5 elements. If you have to find out its uh, arithmetic mean, so simply sum them all and divide their sum by the number of elements 1, 2, 3, 4, 5. 5 elements. So 4 plus 6, 10 plus 5, 15 divided by 5, that becomes 3. 3 is the arithmetic mean of these 5 numbers. Clear? Let me ask of this. Okay, 3, 4, and 5 divided by 3. the arithmetic mean of these three numbers becomes 3, 4, 7, 7, 5, 12 divided by 3. 4 is the arithmetic mean of these three numbers, 3, 4, and 5. Clear? So we may write that if there are any x1, x2, n number of observations, then their mean will be represented by x bar, and you have to sum them all the observations, and divide the number of observations. That will be the arithmetic mean. I hope that's clear. That should make things clear about arithmetic mean.
Yes, sir.
Yeah. So let's say there are two numbers, A and B. Now we have got to make an arithmetic progression. We know that with two numbers we cannot make a sequence arithmetic progressive, because we have to show that the common difference between any two consecutive terms is constant. But with two terms we can do that, right? So we have got to insert some numbers in between these, and what numbers we can insert is, we can insert some arithmetic means in between these two numbers to formulate a new AP. Okay, so let's assume we are going to insert few numbers from A1, A2, and n terms in between A and B, which will make this sequence a arithmetic progression, arithmetically progressive. So if it is going to be arithmetically progressive. So if this sequence is progressive in arithmetics, so we know the difference between the any two terms will be constant. Okay, so for that to happen, we need to insert every number within certain conditions, and those conditions are is that the arithmetic mean of all the numbers. How we can find out the arithmetic means of all the inserted arithmetic means? By summing them all, right? By summing them and dividing them by the number of the terms, and the uh, arithmetic mean of all these numbers has to be equal to the arithmetic mean of these two numbers. So if this is true, then the numbers can be inserted, and then it can formulate a arithmetic progression AP. So if we further simplify it, then we can write the sum of all insertions has to be equal to n into the arithmetic mean of those two numbers. Clear? Any doubts?
No, sir.
Yeah. Okay. So let's now discuss more about this AP. We know that the common difference between the any two consecutive terms are just going to be the same. So why not find the common difference, right? So, okay, let's try finding out the common difference. So we know nth term of an AP is a plus n minus 1 into d. But here we have to read this, that in this particular AP, how many total number of elements are there? How many total number of elements are there? Like there are two elements and n insertions that we have made. So n plus 2, right?
Yes, sir.
Yes, there are n plus 2 total elements in this arithmetic progression. So now the formula for the nth term will become n, which is n plus 2 minus 1 into d. So this becomes a plus n plus 1 into d. Okay, so if you are looking for the first term, for the very first term, that is a. So that should be, if we find out t of a 1, which is a, so it should be given by a plus n plus 1, which is 1 plus 1 into d. So if we further write it, a is equals to a plus 2d. Okay, so a minus a becomes 0, 2d becomes 0, but that is not true. So um, let's apply some different formula. Actually, we can find it out by finding the nth term. Okay, let's try using finding out the nth term. Basically, n plus second term, n plus second term, because this is the first term, this is the uh, n plus first term. No, no, this is not the n plus first term. This is the second term. This is third, this is fourth, and this is n plus one term. This is n plus two term. Okay, great. This is b, and this can be given by a plus n plus 1 into d. Cool, cool. Okay, so now b is equals to a plus n plus 1 into d. Now b minus of a divided by b minus of a is equals to n plus 1 into d. We further write it, b minus of a divided by n plus 1 is equals to d. So this is the common difference. Note it down. B minus a divided by n plus 1 is the common difference for this particular arithmetic progression, because this time only change is that we have inserted few numbers from a1 to an, and the common difference will be according to b and a, and also the number of terms that we have to insert in between. Any doubts? I know this is a little complex, but you have to like understand it thoroughly. So clear? Any doubts?
No, sir.
No doubts. So it's simple that if there is an AP like A, A1, okay, this is A1, A, A1, A2, AN, and B. This is an AP of total n plus 2 terms. Of total n plus 2 terms. Don't mistake by like me, this is the n plus 1 term. No, this is the first term. This is the second term. This is the third term. This is the n plus 1 term, like 2 plus 1, 1 plus 1. Similarly, this is n plus 1 term, this is n plus 2, 2th term. Okay, clear. Now we are very clear about the common difference, which is b minus of a divided by n plus 1. We know that the second term, the difference between these two is d. So if the difference is 2, so a1 will be a plus d, right? Then a2 should also be a common difference away. So a2 should also be a plus 2d. a3 should be a plus 3d. And similarly, an will be a plus n plus d. A plus into n into d, which is a plus n into d is what? B minus of a divided by n plus 1. So it's like b, it's a little complex if we write the d here. That's why we will not. Okay, we can remember it like that. Ki a1 is equals to simply a plus d when we are inserting some elements in this. Clear? So remember it like that. And also the difference is this. And now simply this page is really important for you. And remember that we are inserting insertions of AMs in between A and B to formulate a AP. Any doubts, anyone? If any doubts, please ask. And
No.
also one more thing, the arithmetic mean of this is equals to the arithmetic mean of the two numbers. And this is also the same, also true for any arithmetic progressive, like progression. If there are numbers a 1, 2, 3, 4, 5, 6. Oh, okay, let's say these are in EP. These are in actually in EP with common difference of 1. If we take arithmetic mean of these and arithmetic mean of these two terms, this will be equal. So 6 plus 7 divided by 2. Okay. And 2 plus 3, 5 plus 5, 10 plus 14 divided by 4. Now this is also 7 by 2. This is also 7 by 2. Okay. So this is how the arithmetic means of last terms and the between four terms are equal. So similarly, we have written this also. Clear? So this page is very important for you. Okay, shall we do a question or everything clear?
Yes, sir.
Okay, so there is a question. There are n arithmetic means between 3 and 70. Like there are n arithmetic means. So let's represent by them a1, a2, and there are n arithmetic means in between. If the ratio of the last mean, okay, ratio of the last mean to the first mean is 3 is to 1, then the value of n is, we have to find out this. And if there are like arithmetic means, then definitely the sequence will be in arithmetic progression. How we can find? Now we know an is simply a plus n of d. a1 is simply a plus d, which is 3 is to 1. So let me not confuse you with writing this. This is simply 3 is to 1. So if we further move, and also what is a? 3, right? Okay. So, and also we know what is d? B minus a. So b minus a upon n plus 1. B is 17 minus a minus 3, n plus 1. So we don't know about n exactly. Difference should be 14 upon n plus 1. Okay. We'll utilize this information whenever required. So if we solve this further and cross multiply, so this becomes 3 plus nd is equals to 9 plus 3d. Now nd minus 3d is equals to 9 minus 3, that is 6. Now we have two variables in the equation. We have to find out n. We know the relation between d and n. So we have to find out n. So let's substitute the d from the equation. Taking d common, n minus 3 is equals to c. D is what? 14 by n plus 1. And into n minus 3 is equals to 6. Cross multiplying, this becomes 14, n minus 14 into 3 is 42, right? 6n plus 6, 14n minus 6n, 8n is equals to 42 plus 6, that is 48. Now 48 by 8 is, I guess, 6, right? 8 5 ja, 8 6 ja, yes. So n is 6. Answer should be 6. Let me check. Yes, it is the correct answer. N is equals to 6. It's the correct answer. Any doubts, anyone? That how we have find it out? It's so?
No, sir.
No doubts? Great. Then please observe the question. Now we actually don't had to apply much of our mind because we remembered the result this D and how arithmetic means are given. Simple. It's like simple. Just when we find the nth term, we write a plus n minus 1 into d. This time we'll write a plus nd, a plus nd, a plus nd. Great. So let's move ahead and discuss about another progression, which is interesting to discuss. Geometric progression. Now, earlier the progression was of arithmetic nature, means it was somewhat increasing with some constant difference, or some negative common difference could also be there. Now, this time we'll not deal with addition or subtraction. We'll deal with multiplication of some ratio or the division of some ratio between the two terms. Right. So as you may guess it, this time we are not going to have any common difference, but we are going to deal with ratios. We so Earlier we used to define an arithmetic progression like any two consecutive terms will have same constant difference. Now this time any two consecutive terms have common ratio. Let's say there are terms T1, T2, T3, T4. So let's okay. So T2 divided by T1 should be equal to T3 divided by T2 because it's a ratio. T4 divided by T3. Okay, this is how the common difference should be the same. Earlier, in case of AP, if like A, B, C, D are in AP, okay, then we used to say B minus of A should be equal to C minus of B should be equals to D minus of C. Basically, the difference between these consecutive terms should be equal. Now, this time the ratio of the consecutive terms are equal, taken in an order, of course. Okay. So this is the new thing that we are going to study. Any doubts, anyone? Any doubts? No doubts? Okay, great. So it's a geometric progression. So let's now first understand the condition for three terms A, B, C to be in geometric progression. So if A, B, C are in geometric progression, we know B by A has to be equal to C by B. If we further solve it, we can write B square is equals to AC. If B square is equals to AC, we may write A, B, C are in GP. If A, B, C are in GP, we may write B square is equals to AC. If B square is equals to AC, then we may write A, B, C are in GP. Okay, it's true on either sides. Clear? Clear? Are you clear with the condition of uh, geometric progression? Everything clear? Okay, so as we discussed about the general term in arithmetic progression, this time also we are going to derive the general term of and discuss about geometric progression. So as always, the first term is always important. So considering let the first term is A, and this time the common ratio is R. Okay, so the first term will be A, the second term will get multiplied with R, this third term will get also get multiplied, and so on and on. So if we may observe, the first term is A into R raised to power 0. The second term is A into R raised to power 1. So this is the second term, this is the first term, this is the third. So similarly, the nth term will be a into r raised to power n minus of 1. So the general term for an GP is a raised to power r a into r raised to power n minus of 1. Clear? Any doubts? Where a is the first term and r is the common ratio. I don't know how have I written m, where r is the common ratio. Clear? Any doubt about the general term of GP, nth term? Any doubts, anyone? Okay, so let's now try to find out the sum of n terms. So the GP was looking like this. These are n terms of GP, right? So if we may find out the sum of, let's say the sum of first term is A. Sum of two terms is A into A plus R. Sum of three terms is A plus AR plus AR square. So similarly, the thing is also clear here that sum of n terms, if we subtract it from sum of n minus 1 terms, so it will give us the nth term, provided that n should be greater than 1. That means n can be 2 or greater than 2. This is the condition for it. Anyways, let's if we observe it, taking a common, that this becomes 1 into r. Taking a common here once again, so this times it will become 1 plus r square. Fourth time, a sum of four terms. So a plus ar square, ar cube. This becomes a into 1 plus r square plus r cube. Okay. So we may conclude it by saying that that the sum of n terms is somewhat becoming a to getting multiplied with a minus of r raised to power n minus n divided by 1 minus r, or a into r raised to power n minus 1 divided by r minus 1. Okay, this we can use them conveniently when r is less than 1. We can use this for r being less than 1. For r being more than 1, we can use this. Clear? Any doubts? Anyone? And how have I written? So let's say, let's write it in this format. So sum of two terms should be a is equals to 1 minus of r square divided by 1 minus r. We know what is a square minus b square? A into a minus 1 minus r into 1 plus r divided by 1 minus of r. This cancels this. This becomes the same. That's why this is an identity. That's why we have written 1 minus r raised to n divided by 1 minus r, or vice versa, or the sign is changed. Clear about the sum of n terms? These are the sum of n terms of GP. Let's say if there is a sum, if there is a GP, we have to find out that it is infinite GP. Okay, so the condition for finding out the sum of infinite GP, AR square, so on and on. So if it is going till infinite, we'll be able to find out the sum of infinite terms only when the common difference, the modulus of common difference is less than 1. When the GP is becoming less and less with time, so that after infinity it will collapse. Then only we will be able to find out its solution. So for example, 1, let's say 4, 2, then 1, then 1 by 2, 1 by 4, 1 by 8, 1 by 8, and it is going to infinite. So we know that the common difference is here 2 by 4 or 1 by 2. So the the common ratio is 1 by 2, which is less than 1. Now we are able to find out the sum of infinite terms, and that will be given by simple this formula. Sum of infinity terms, a into 1 minus of r. Why? Why this? So we know the sum of n terms is a into 1 minus of r raised to power n, 1 minus of r. Okay, now the n is infinite here, a into 1 minus of r raised to power infinite divided by 1 minus of r. We know r is less than 1. Okay, if we if we like take assume its power to be infinite, and we know r is less than 1. So if something is like 1 by 2, if we raise its power to very big number, so it will almost approximately become 0, right? So similarly, we have assumed that its value is 0, and a into 1 minus of 0 upon 1 minus of r. Now this becomes a upon 1 minus of r. That's how we have written the sum of infinity terms. Only it will become r raised to power infinity will only tend to 0 when r is less than 1. Only when r is less than. Clear? Any doubts, anyone? Any doubts?
No, sir.
It's a very valid point that in a manner that I have explained the sum of infinite terms. So the sum of infinite terms is a. Here also we can find out a, which was 4 upon 1 minus of r, which is half. 1 minus half is half only. Now the 2 will go into the numerator and becomes 8. So 8 is the answer. Simple. That's how simple it is. Clear? Any doubts? Any doubts?
No, sir.
So yeah. So this is geometric progression. So if no doubts, shall we conclude today's class now?
Yes, sir.
Yeah. Okay, then. Thank you, everyone. Jai Hind.
Thank you, Sanjay.
Oh, Tanish, you have became brigadier today.
Thank you, sir.
Yes, thank you.